Well, hello everyone. So welcome to Cloud Native Python. So today we'll be talking about all aspects of Cloud Native Python. We don't have a ton of time, so I'd love to dive into the areas that folks find most interesting. So feel free to keep this very interactive. I'd love to hear about people's current experience with Cloud Native things, whether that might be just getting started, Dockerizing, containerizing your applications, all the way up to things like container orchestration. But at the moment, what we're looking at particular developer workflows and some services and things that can sort of help you along that journey. So don't feel like you have to have any previous experience around this sort of thing. This is mostly how these tools can help Python developers and a particular workflow that I think is quite interesting. So I'm going to start off by looking at some of the tools that we sort of have in this space for people who are starting to containerize their Python applications. So a lot of folks are familiar with Docker, and we have a fantastic Visual Studio Code extension for Docker, which takes away a lot of the pain. If you haven't previously had exposure to Docker, you install Docker on your local machine, you can go to our website and you can install the Python extension for the Docker extension for VS Code. And we have this fantastic tutorial which shows you how to containerize a Python application for the first time. And this will basically break it down and let you create your first Docker file. So you don't need to know the internals of how to create a Docker file. It has some opinions and so forth baked into it. And all of this can be done by the Visual Studio UI. And it's a great place to start whether you are building something which could be a Flask application, a Django application, or something like a Fast API, which is what I'll look at here. So we have both this tutorial and we have a sample application which you could find quite useful there. And it helps you both create the Docker file, build your Docker container without going off to the CLI, and then use Docker, create the container, tear it down, etc. It's very good in that regard. So the application that we'll be containerizing, so after we start, we need an application of some kind, which is typically an API or a web endpoint, will be the Python Fast API sample. And this is just a very simple example of a single endpoint Fast API application, which you can pull down. And as you see in this repo, there's no Docker file, there's just a main.py here, and we have a single endpoint, which you could use as a sort of a stub to build out your own application. This one is importing Fast API and Unicorn in the requirements.txt here. But if we go over to our VS Code, we're going to take this, we'll pull it down and use that as the stub for our Python application that we're going to bring into the cloud native and containerized sort of mindset here. So if we pull this down and we hop into this, we need all of this at the root of our workspace. So we pull this down and we pop it at the root of the workspace. So you can see you've got the main.py here. I'm just deleting that folder for you. And then you can see that we are going to open up the main.py, have a quick look and see this is our single endpoint application. It just says, hello, Azure. Fast API, excellent for building up fast APIs. It's sort of all in the name. But we go through here and we can open up the menu and run the add Docker command, and then we can run add a Python Fast API Docker file there. So that's going to automatically generate the Docker file for us. You can use it for lots of different languages, and it's got a few sort of opinions and other things baked in there for us. So if we continue on, it'll ask us for our main.py, the file that we're going to run, the port, and then the Docker file. So it also gives us the option of using dropping in here Docker Compose, where you can use Docker Compose with multi-container applications, and you could start up a database alongside your application, like a Postgres or a MySQL or something like that. We've kind of skipped over that at the moment. All we want, in addition to our application here, is a Docker file, and you can see that we've set a number of environment variables and other things here that will help people the first time they containerize their application. So things like not buffering the output, so that when you look at your Docker logs, you'll be able to see these that are coming out of the container in real time. And if you haven't seen a Docker file before, This is the syntax. We have a series of commands, which it builds up your Docker file, does things like set environment variables, copies things from your local file system into the Docker container image, and then can run commands such as pip install. So we're installing our requirements, and it's building up this container image, which will then get built up, and then we'll later on be able to run our application. We're doing a few things here, like creating a directory, copying all our source code into that directory, creating a user, which is a non-root user, which is quite important from a security perspective. And then finally, the command that runs the container, we're running our web server, and we're specifying the application that we want to run. So we'll end up with this Docker image, this container image, which will then be run, and then that becomes a running container when it's actually running. But how many people here have been containerizing their applications already, or have been sort of already down this road with Docker so far?
And folks, you can feel free to unmute, or also feel free to just drop some comments, whatever you're most comfortable with.
So one of the things that I find is very important is making these kind of containerized workflows accessible for people who aren't really into the ecosystem already. And I find the VS Code extension is quite powerful in that regard. So it enables us to build the image very, very easily. Oh, sorry. And if anybody wants to say hello, just feel free to interrupt. And even as somebody with a lot of experience with this, it was very much a productivity enhancer early on. You don't have to memorize a whole bunch of different commands. It brings it all into VS Code where you're actually hacking on your application. And you can see here that we're just looking at our pip, our requirements.txt, and we're importing two libraries here, Fast API and Unicorn. Because we are running our application, we're going to need to input this Docker file here. It's running Gunicorn. We're going to put that inside of our requirements.txt in just a little bit. But we're going to take this and we're going to build it. So we run the build command via the application here, and we can see the image is going to be built. So I've installed Docker on my machine. It's building my container image in the background here from my Docker file, installing all my requirements. You'll see this will fail because the Docker file that I've just created actually depends on Gunicorn. So we're going to see that come in a second. But it's built the container image, and we're going to open the image browser up here, and you can see we have an image right here in our menu here. And now you could find this by running Docker images, and then we can go down here and find a specific tag, and we can run it, and we can see that we have an error. So if we go back to our requirements.txt, and we add Gunicorn in here, and then we go back and we run the build image command again, you'll see that all the layers that we built before are cached, and the second build is much faster than the first one, or relatively faster than the first one. It's now got the right dependency in there, and we're going to run that image again. And it's called Cloud Data Python. We're running the latest tag, and you can see that's running in the background. I didn't have to open another terminal or anything like that. It's just running right there. And now I can just curl that endpoint. So this one is listening on localhost on port 8000, and you can see my API endpoint. So at core, that is the simplest way of having a Python application, which could be a web application or an API of any description, and just getting it very quickly Dockerized. And in the cloud native world, the container is the contract, and that gives us the ability to run it across any of these containerized platforms that we can use in the cloud. It's very much worth getting to this point for all the goodness that you can use in the container world. And I'll go over a couple of different options that we have here. But once you've got a container running on your local machine, the next stage is to be able to distribute that either for people in public to be able to pull that down and use it in a containerized form. Maybe you're distributing your application, something that developers want to use, or open source consumers want to use. And you need to get it out there, or it could be internal to your organization. You want an authenticated distribution mechanism. The next stage is a container registry. And one of my favorite ones is actually the GitHub container registry, which is baked into every GitHub account now. We have this thing called the GitHub package registry. If we just go through here, you can see this is the homepage of my GitHub account, and you can see there's this packages tab on the right-hand side here. And you can see there's a few images here. These are all Docker containers inside of my container registry baked into my GitHub account. And there's a really good tutorial here that just helps you get up and running, setting up your images. It's free for public images. You can build containers and deploy them to the container registry or push them to the container registry. You authenticate your local tooling against it. So you can build a container, push it up here, and it's very, very efficient, fast, efficient, and publicly accessible for free. The way you authenticate against it is by getting your personal access token from inside your developer settings inside of GitHub, and then using that as a password for your local Docker tooling. So you're going to need to set an environment variable if you're authenticating local Docker against it, and then this explains how to do it, and it explains the permissions that you need to be able to give this token so that you can actually push images to your container. So we see here that we've got this CR path environment variable, and we're going to need our personal access token over there, and then we're going to run the Docker login command. So once you've done this, you only do it once. Your local tooling will be authenticated against the GitHub package registry, and you'll be able to push your local images to the cloud. And that's the Docker push command you can use. The images are available at ghcr.io/your name or your organization name / the image name, and then with the fully qualified tag as well. So this is a great way of going about it. The second option, which is one of the reasons I'd use GitHub Container Registry in the first place, or GitHub Package Registry, is that you can easily access it via GitHub Actions. So with this GitHub Action workflow that we have here, this can use the authentication that is baked into your GitHub Actions workflow using the GitHub token that is injected as part of this, as part of the workflow, to actually build your container inside of a GitHub action and then push it to the container registry all in one shot. So you have the local development workflow, and then you have the cloud development workflow where you can just drop one of these inside of your GitHub repository. So this is what my local CR path environment variable looks like. So I'm using the built-in terminal in the editor window, which is a great part of VS Code right here. And I'm just showing you the example of the script, this onv.sh that I have here, which has my real token baked inside of it. And now I'm going to just run that onv.sh, so I have this environment variable so that I can run the Docker login command. And I can send out this repository when I'm finished, but you can see here that I've got a number of scripts here for various kinds of container workflows to build and push my container. There's 3 that I'm listing here. One of them is the GitHub Container Registry, which we're going to show off right now. The other one is the Docker Container Registry. So if I want to be able to build using a local Docker build and push to Docker Hub or something like that. There's another workflow which shows how to use the Docker buildx command to build on something like a Apple Silicon device, which I'm running here, and cross-compile that effectively to a AMD64 so that my container service can run that in its native architecture rather than my ARM architecture that I'm running locally. And the other one here that I have is for our Azure Container Registry, which allows you to build your container inside of the registry itself, so you don't even need Docker running locally. So the 2 workflows I generally recommend are building and running locally for your development purposes, and then pushing to something like GitHub Container Registry, which is where you can also use GitHub Actions to build it on push of code to your repository. And the second workflow is where you would take your code and then push it into a private container registry like Azure Container Registry and have that handle the build and all of that sort of thing for you as well. So if we go through here, you can see this is the command that I run, this ghcr login.sh, and it's going to just run a Docker login command so I can push my container up. And do we have any questions so far? So if we have a look here for a moment, you can see that I've got this sort of helper script, the ghcr-push.sh, and I'm setting some bash variables here with the owner, which is effectively my GitHub username, the local container image, which could be different locally. In my case, it's called Cloud Native Python. The remote container image, which is I'm also going to rename Cloud Native Python, and the tag. And you can see that the fully qualified name when it gets out there is going to be ghcr.io/ASW101/ in this case, we're going to change this to Cloud Native Python. And we'll also make the public image Cloud Native Python. And if I save this, then I can just run this ghcr push each time, and that will just push the local image up to the cloud with the tag latest. So if I just run bash, do ghcr-push, and that's going to push each layer of my image up into my GitHub container registry. And each line that you saw in the Docker file is effectively another layer that gets built and packaged into the Docker file and gets cached as well. So if you have something which installs a lot of dependencies, that particular layer will get cached and it won't need to be pushed up each time if it is, unless something changes at that particular layer. So once that's pushed live, you'll be able to go over here and look at the GitHub packages tab inside of GitHub. And if you scroll down to the bottom, you'll see we have a Cloud Native Python image there, and it's private by default. There's lots of other metadata and other bits and pieces that you can see here. But if you scroll right down to the bottom, actually over here under package settings, if you scroll all the way down here, you'll be able to see that we can change the package visibility. And what that enables us to do, just like a GitHub repository, we can change it from private to public. And then anybody will be able to pull down, if we go down to the packages, back down to the packages tab, scroll down, go down to Cloud Native Python. Anybody now will be able to pull this container image and deploy it to their own service or run it on their local machine, etc. So you've got to the stage, you've got from code to container image to the cloud, sorry, not to the cloud, to the publicly hosted container registry. And that buys you a lot of flexibility as to where you can deploy your application. Now, one of the thing that I wanted to talk about here in terms of the deployment option is a new service we have inside of Azure called Azure Container Apps. It's brand new, released a few months ago, and it enables developers to run containers in a fully serverless manner, which scales all the way down to 0 and from 0, and it was also built in a serverless manner. So just like you have a serverless platform like Azure Functions, you can now take advantage of the serverless billing model to be able to run containerized applications, which might have more dependencies, which might need to scale out in specific ways, which might need to run in response to HTTP requests, which is an incredibly common use case, or run as a background application. So the application that we've just containerized right now is a simple API. It's a containerized API, which we're going to deploy to container apps. And we have this really good quick start here. So if you have a look at this quick start, which talks about how to deploy your first container app, we'll just use this to show the different elements that are going to up and running. You need the Azure CLI to be able to deploy this for this particular tutorial. And you'll just log into the Azure CLI. We can install the extension and run this other command. And these are things you only need to do once. But once you get down here, we'll be setting up some bash variables which name the resource group, the location where you'll be deploying container apps, and a couple of other names like the log analytics workspace, the place where the logs get aggregated and are queryable from, and also the name of the environment. Once you've got one of these up, you can deploy container apps to it, and you only really need to do it once. These are the commands that will be running to do things like create the resource group, create the environment. So first we create the log analytics workspace, which is where the logs for this environment will go. Then we will grab a couple of other things and create the environment itself. And then from that point, you only need one command to be able to deploy any containerized application to the cloud. So this is the Azcontainer app create command, which has, you give your container a name, you specify the resource group where the container apps environment is, you specify the environment that you're deploying to, and then you will provide the image, the fully qualified name to the image that you want to pull down. So in this case, we're going to be deploying our public image. In fact, we'll start by deploying the sample image, and then we will specify the port that it's listening on, that it has an external ingress. So this is publicly accessible to the internet because it's possible to have private, inaccessible instances of these two. And then it'll also output the fully qualified domain, which it'll provide for you. So once you've done all of this, we're going to pop over to a terminal in just a second. You should see you'll see a sample application like this. And once you finish deploying this, if you're following along afterwards, you want to blow away all of this by deleting the resource group so that you're not billed for anything. So if we go to our terminal here inside of VS Code, you will paste the environment variables. So these are all boilerplate. You don't need to think about special names for them. You might want to choose a different location. If you somewhere else other than Canada Central, which is up here in Toronto, I'm dialing in from. We just created a resource group using AZ group create. Then we have AZ monitor log analytics workspace create. This creates a workspace where the logs will be streamed. And there's a great example inside of the docs there on how to query these. There's a very powerful query language called Custo query language, which lets you query the logs from your containers and many other metrics and so forth, including seeing how many containers have scaled out, etc. And then we run the Azcontainer app environment create. Now this is the one that'll take a few seconds because you're creating this environment once. It's actually run by Kubernetes under the surface, and it uses other open source projects such as Envoy, Kubernetes event-driven autoscaler, and one of our most popular cloud-native projects called Dapr, distributed application runtime. And all of these are available within this container apps platform. And I know we only have a short amount of time today, but if you're in our Discord, I'd love to chat with people. If you have any interest in this, this platform or serverless containers or the open source projects underpinning it in particular, you might find that quite. I'd love to chat more and see how people are interested in using them and the sorts of things that they find useful. So that's just creating now. And then finally, we can run the Azcontainer app create command. Now this is quite fast, and you can see you're using the sample container image over here. I'll give you the time, Luciana.
I think we can keep going for a couple of minutes. We've been late a little bit here and there, so it won't work out.
Oh, should be done in a couple of seconds, and we'll go have a look. So excellent. So the moment the container is deployed, you can see that we now have a fully qualified endpoint to azurecontainerapps.io with the region, and we got the name of the container, the name of the container app, And then we also have the second part of the URL, which specifies what we call a revision, which I'll show you in a little bit. But basically, these applications are deployed with multiple revisions that you can route traffic to. We can split traffic between revisions. We can make sure traffic sort of moves over smoothly from one revision to the next. And that's sort of baked into the URL there. So if we go here, now we're going to switch over to the Azure Portal, and we'll just take a brief look at what we've deployed.
And the good news, you can keep going because James will only need 30 minutes for the next hour. So you have 30 minutes extra if you want to.
Excellent. Thank you, James. Much appreciated. Yeah, I know I've been rushing through this a little bit, but if people have questions, I'd love to hear, if you're using serverless containers platforms, if you're looking at these sorts of things, you're building APIs, building web services, which is a very key use case for this. So you can see that we've just deployed a resource group inside of Azure called My Container Apps, which is the default name. And then we're going to hop into that resource group and have a look, and you'll see that we have three things. So we have our Container Apps environment. We have a log analytics workspace where all the logs and etc. will be coming out of the Container Apps environment and our Container Apps, so we can query them both via the CLI and the UI. And then we have a Container App. So we can, let's have a look at the environment first. And then we go over here, we can take a look at the apps inside of that environment. You can see we have a Container App in Canada Central. Got the application URL, and this is our sample application running on the internet on a publicly accessible endpoint, which also has TLS termination. So this is one of the advantages of this managed platform. You don't have to worry about things like TLS termination, DNS routing, and a bunch of other things that you have to set up if you're working with a Kubernetes cluster, etc. But these are all open source building blocks. This is built from open source building blocks that you can also take the same application and the same open source projects, and you can run them on your own Kubernetes cluster, inside of Azure, on premises, as you wish as well. So this is, you have portability between the managed service and the bring your own open source stack as well. You can also use secrets with Container Apps as well. If we go here in the secrets tab, you can see that we have a secure way of injecting things that might be query strings. We're just going to create a new secret here. We'll call it hello. Way to make that smaller. And we can give that a value, and that will be available to our application as an environment variable. We have ingress. We can choose whether our application is publicly available or not, or limited to traffic from within our own Container Apps environment. We can specify the port that our application is listening on. And then each application is deployed, which version of our application is deployed as what we call a revision. So we can see here that we have one revision by default, and it gets 100% of the traffic, and it is active. It's actively receiving traffic. It tells us when it was created. And if we create another one, we can roll back to the old one, or we can split traffic between them. We'll click on the revision, and we can see inside of the revision, we have a container. We have some scale options, and we have the ability to turn on the distributed application runtime. So if you have a look at the container, this one has 0.5 of a CPU core, 1 GB of RAM. We can see that it's scaling from 0 replicas to 10. So when the application is not getting any traffic, it will scale all the way down to 0, and you won't be billed for it at all. Container Apps has per request billing. There's I think there's 40 cents per N requests, and you also pay per gigabyte second. Well, combined gigabyte second, there's a great calculator which you can use to determine the cost in a serverless manner for your entire Container App application. But this will scale all the way down to 0, so you're not paying for the compute or the RAM when you're not using it. And then if we go back here, we'll go into the container and see we also have the ability to have environment variables to change the command. So we'll go back to where we can change it. We'll deploy a new revision. So we go to My Container App, create a new revision. And in this case, we'll just change the container itself. So if we go to the container. One thing I will mention here is that a container app is also not just a single container, it is a pod. So if you're familiar with a pod from Kubernetes, a pod is one or more containers that run together in the same namespace. So effectively side by side, they can access each other's resources. If you have an application and you have another process, which is a cache for that application, these should be or can be run together as a single pod, or you have one application and then you have some logging, something that emits logging or some kind of other sidecar process for that. You can run multiple containers inside of each container app. So I could add a container, but in this case, I want to modify the existing container. So I'm going to edit this container. We'll leave the name the same. You can see that we can pull from a private Azure Container Registry, or we can go to Docker Hub or other registries. So we're going to use the GitHub public registry, and we're just going to update this to show our, to point to our public image. So we'll go grab the name of the container that we had before, which was what's it called? Cloud Native Python. So this is ghcr/ASW101/Cloud Native Python, and the registry login server will need to be ghcr.io, and then the fully qualified name of the image combined with the tag will be the ASW101 portion over here. So I'll paste that over there, and then we can click save. Now we can change it so that it can always have at least one replica running at all times, and you'll pay for the in this case, the 0.5 gigabytes, I think 1 core continuously. Or we can scale this right back down so the minimum replicas is 0, so that when it doesn't receive any traffic, it will scale all the way down to 0. In this case, we'll make the maximum number of replicas 5. And this is also the distributed application runtime. This is an open source project which enables applications to helps developers build distributed applications from any language and on any platform. So it enables, say, a Python developer to build an application which needs to access multiple different types of blob storage or multiple types of databases if you need assistance, if you need inter-application communications. There's lots of different key value stores, secrets management, streaming data, lots of capabilities, which I won't be able to go into now. But this is all available. You can just turn it on and your application can be effectively Daprized so that it can access all of this capability from within container apps, which is also available on top of Kubernetes as well. So we can see now that we're going to be deploying that revision, and pretty soon that will be up online and show our Python app. But I know we're at time, so if I just hop over here.
Yeah, that was great.
We kind of flew through that a little bit. I'd love to talk to anybody who's interested in digging in deeper or talking about the open source projects that sort of underpin that. If you have any questions, feel free to say hello on the Discord. I'll be around today and tomorrow and